Imagine standing outside on a blazing summer day when the heat is almost unbearable on your skin. Now imagine moving closer to the sun itself, where temperatures rise not to hundreds, not to thousands, but to millions of degrees. And the question is, how do humans know that? How can we measure the unimaginable heat of a star we cannot touch with any instrument? In this video, we will uncover how science truly measures the sun's temperature. We will explore each layer of our star, the techniques used, the incredible instruments that make it possible, and why this knowledge matters for every single person living on Earth. The sun is not just a ball of fire, it is made of layers, each with its own temperature. At the very core, nuclear fusion turns hydrogen into helium, creating enormous amounts of energy, and the temperature there reaches about 27 million degrees Fahrenheit. That energy rises through the radiative zone and then through the convective zone where giant bubbles of plasma move like boiling water. Finally, it escapes through the photosphere, the surface we see shining in the sky with a temperature of about 10,000 degrees Fahrenheit. And surrounding all of this is the corona, the outer atmosphere that mysteriously burns millions of degrees hotter than the surface. We cannot place a thermometer on the sun, so scientists turn to light itself. Every hot object glows with colors that reveal its temperature. Metal heated in a furnace glows red, then white, and the sun's light does the same. By splitting sunlight with a spectrometer into a rainbow of colors, scientists can see dark lines that reveal which elements are present. From the brightness and position of these lines, they calculate the surface temperature at about 10,000 degrees Fahrenheit. The core is hidden and cannot be observed directly, but nuclear fusion produces ghost-like particles called neutrinos that escape instantly. Trillions pass through your body every second without you noticing. Deep underground detectors like Super Kamikonde in Japan or the Sudbury Neutrino Observatory in Canada capture a few of these particles. From their energy, scientists confirm that the core burns at about 27 million degrees Fahrenheit. The strangest part of the sun is its outer corona. It is thin, but somehow hotter than the surface, reaching millions of degrees. It's like standing away from a campfire and feeling the air grow hotter. To measure this extreme heat, scientists rely on space telescopes because ultraviolet and X-ray radiation cannot pass through Earth's atmosphere. Missions like SOHO, SDO, and Hinode detect high-energy light from corona plasma, and from its wavelengths, the temperature is calculated. In 2018, NASA launched the Parker Solar Probe, a spacecraft that flies closer to the sun than any human technology before. It does not carry an ordinary thermometer, but instruments that measure particles in the solar wind and magnetic fields around the sun. The data help reveal why the corona is so incredibly hot. Alongside it, the European Space Agency's Solar Orbiter provides the closest images and maps of magnetic structures, giving scientists an even deeper view of solar activity. Knowing the sun's temperature is not just curiosity, it is survival. Sunlight drives photosynthesis, climate, and weather patterns, but the sun can also be dangerous. Giant eruptions of plasma called solar storms can knock out satellites, disrupt power grids, and cut communication around the globe. By measuring temperatures and activity, scientists can predict space weather and protect the technology that modern life depends on. It may seem like scientists are only making guesses when they talk about the temperature of the sun. However, every number actually comes from real measurements using real instruments. At the surface, we use spectrometers that split sunlight into a rainbow, and from those colors, we calculate the photosphere at around 10,000 degrees Fahrenheit. Deep in the core, underground neutrino detectors capture ghost-like particles created by nuclear fusion, and from those signals, we confirm that the heart of the sun burns at about 27 million degrees Fahrenheit. In the outer corona, space telescopes detect ultraviolet and X-ray radiation, showing us plasma heated to more than 1 million degrees Fahrenheit. And with spacecraft like the Parker Solar Probe and the Solar Orbiter, we now get closer than ever, sampling the solar wind and mapping the magnetic fields that heat the corona. Together, all these tools provide evidence for each layer of the sun, so our picture of its incredible heat is not just theory, but a reliable measurement built from different scientific methods. So the next time you feel the warmth of sunlight on your face, remember that the journey of that heat began 93 million miles away in a core burning at 27 million degrees, traveled through a surface of 10,000 degrees, and passed through an atmosphere hotter than 1 million degrees. Even though we will never place a thermometer on the sun, with light, with neutrinos, with X-rays, and with daring spacecraft, we have measured the beating heart of our star. The sun is not just a bright dot in the sky, it is the source of life and a reminder of how far science can go to uncover the secrets of the universe.